Hello, everyone. Thank you so much for joining us today. I'm Bennett Richardson, the General Manager of Protocol. We're excited to host today's conversation on computing at the edge. 2020 has been a year of transformation of our lives, transformation of businesses going digital faster than ever before, but also the transformation of how we create and use data. And this explosion of data, especially the data from our interactions with the physical world, is why it's so important to understand the concepts of edge computing and the challenges and opportunities that exist at the edge. I want to thank our partners at Intel for making today's event possible. To kick things off, I'm excited to introduce Intel's Steen Graham. Steen leads a team that enables the ecosystem with cutting-edge AI and IoT products, developer tools, and solutions that reduce the time from prototype to business outcomes at the edge, merging the physical and digital worlds. Just giving Steen 1 second to jump on here. Sorry for the delay here, folks. While we're waiting for Steen to jump back on, remember to ask any questions using the Q&A function at the bottom. We'd love to hear your questions for the panel. Hey there, Steen.
Hey.
Awesome.
Hey, Bennett, thank you for that kind introduction.
Of course. Yeah, no, my pleasure. And thank you for being here today. Appreciate the partnership, and I'll let you take it away.
Awesome. Well, I'm really excited to be here today. As Bennett alluded to, computing is becoming woven into the fabric of every industry and every part of our lives, connecting the digital and the physical worlds. And this is driving industry transformations and enriching the lives of everyone on Earth. The former 1997 Time Person of the Year and CEO of Intel, Andy Grove, once said, "You can be the subject of a strategic inflection point, or you can be the cause of one." And what Andy meant was, you can drive industry transformation and disruption, or your business can get disruptive. And there's probably no greater technology in the world today than edge computing powered by AI, 5G, and IoT, driving this industry transformation and disruption. Let's just look at the retail sector today. One of the biggest challenges in the retail industry is inventory distortion, having too much or too little inventory. It's a $1 trillion problem. Using capabilities like autonomous mobile robots to manage inventory and IoT AI-enabled data, we can ensure that the right person gets the right product at the right time, and we solve that $1 trillion problem. So I think these use cases that I talked about and more mean that this next decade, we're actually going to create more data outside of the data center and analyze that data at the edge than in the cloud. And why is that? Why would we analyze data at the edge? Well, there's really kind of 4 laws that we can talk about. The laws of physics. We're limited based on the speed of light. And making sure that autonomous vehicles and fast-moving devices are operating under those confines where they can manage real-time insights and information. The second law that we look at is the laws of economics. It's just not economical to transfer all of this data we're going to create at the edge across the network to be computed and analyzed in the cloud. With edge computing, we can discard irrelevant data and only send up pertinent insights and metadata. And the third law we look at is the laws of the lands. We have to comply with the local government and privacy requirements like HIPAA or GDPR. So edge computing gives us the capability to anonymize critical private information at the edge before we send the metadata or insights to the cloud, compliant with those laws. And finally, and perhaps most importantly, is Murphy's Law. Anything that can fail will. And when we start weaving the fabric of computing into every industry and vertical in our physical world, we have to ensure that these trusted applications don't fail. Edge computing provides us a distributed computing methodology from the cloud to the edge that gives us the fault tolerance we need to operate in real time. So what are some of the challenges of companies in deploying at the edge? Well, there's really 3 major challenges we see. Deploying on the legacy infrastructure. You're not going to build a new hospital or manufacturing facility just because of edge computing. So how do we deploy on existing infrastructure? And how do we transition developers both from the cloud to the edge, but also from an IT infrastructure to an OT infrastructure? And ultimately, how do you navigate this fragmented, diverse ecosystem? Well, at Intel, we're solving these challenges on 3 fronts. 1, with products that are purpose-built for the edge and optimized for the ruggedized, unique experiences of the physical world. 2, we have a portfolio of developer tools to enable developers with the capabilities they need to run AI at the edge, to run 5G, and to run rich, immersive media experiences like streaming and augmented reality. But we go even further than that. We want to provide developers an experience so they can have reference implications and deploy at the edge in industries like retail and industrial. So we offer toolkits to do just that. And even for developers that want to run 5G, private networks, and run AI on the same infrastructure, combining both an OT, IT, and communications technology workload, we offer toolkits to do just that. Companies today are deploying 5G networks with access control capabilities for their factories on common infrastructure, providing them the ultimate total cost of ownership. And to address the challenges of the ecosystem, Intel has an initiative called Market Ready Solutions, where we have over 300 end-to-end solutions that drive the ultimate time to business outcome for enterprises. These solutions have been proven in the marketplace. Everything from cold chain monitoring to autonomous mobile robots for inventory management. Enterprises are getting business value today through that initiative. Now at the start of the call, we talked a little bit about how Andy Grove mentioned you could be the subject of a strategic inflection point, or you can be the cause of one. Edge computing is driving the strategic inflection point in the world we live in today, and it's only accelerated based on the pandemic. What we're seeing today is edge computing deployed using robots and ultraviolet light to solve challenges like cleaning hospital beds so our nurses can stay protected and safe. We're using edge computing to do spatial distancing and monitoring folks so they stay a certain safe distance away. We're using edge computing for touchless retail experiences so we don't transfer germs. And we're using edge computing capabilities to do diagnosis in medical images faster and remove bottlenecks in that process so doctors can focus on treating patients. Edge computing has a truly transformational impact on the world we live in today, and that will only be accelerated over the next decade. I'm excited to learn more from Tom and the panelists today. Thank you so much.
Thanks very much, Steen. Appreciate that. And without any further ado, let's get into our panel. I am thrilled to have 4 experts in edge computing, AI, and IoT joining us today. We have Farah Papayino from Edgeworx. We have Robert High from IBM, Nancy Lee from Cox Communications, and somewhere out there on the edge is Simon Crosby of Swim AI. Thanks everybody for being here.
Yeah, thanks, Tom. Appreciate you having us.
Thanks for having us.
So I wanted to start off, we just heard a little bit from Steen about how Intel sees edge computing, and I wanted to hear from all of you a little bit more how you see it. How would you define edge computing? And why is this an interesting topic right now as we consider application deployment models and infrastructure strategies? And whoever wants to jump in first, go ahead.
Well, I actually think Steen had it right when he talked about having a cloud to edge continuum. And so the way we see it, or at Edgeworx, is that anything outside of the cloud would be considered the edge. I know a lot of people like to think of endpoints such as autonomous vehicles or robots as purely being the edge, but people are more sophisticated than that, and they're not just going to have things sitting at these endpoints and then things sitting at the cloud. What we're saying from our customers is that they have just a myriad of different edges that they kind of bring together to form a solution. So they'll run things on the endpoints, they'll run things on micro data centers, they'll run things on physical colos, they'll run things in the cloud, and this will kind of form this like continuum where they'll deploy things out at different levels depending on the application they want to run.
Yeah, if I could add on to that, I just really think there's a confluence of three trends that are occurring that are all kind of reinforcing edge computing. Number one, I think that the equipment manufacturers are finding it not only cheaper in many ways, but in fact, certainly better to infuse compute into their equipment. And I'm talking about everything like, from industrial robots to automobiles to industrial intelligent cameras, et cetera, the things that we've been talking about, the things that Farah brought up. And I think what that's opening up is this idea of a software-defined product, right? The idea that you can unlock feature and value and function by virtue of the software that you build into your product and use to enhance its utility. I think that's one trend. I think another trend is really what we've been seeing in the telco industry around the introduction of 5G and sort of the capital that that's unleashing that is bringing investment opportunity into exploiting edge computing, but more so driving innovations that I think are somewhat enabled and certainly accelerated by 5G. I won't go as far as to say that edge depends on 5G because I don't think that that's true, but I do think that 5G enhances and expands what we can do at the edge. And I think the third trend really is largely the whole digital revolution or the transformation that most businesses are going through to become more digital. And I think that digital enterprises require deeper levels of engagement with both their employees and their clients. And I think that's only possible when you consider some of the things that Steen talked about in terms of latency, bandwidth, privacy, et cetera. All of those are kind of key to enabling the digital experience.
Yeah, I think the edge depends on the definition. The application is different, and whether the input, the values you bring to customers is very different. And for example, for NVIDIA chips, they call them also the edge. They bring some like high GPU compute to the chips, and their value to customer is being able to process the data on the chipset much faster. And from telco perspective, and lots of telco nowadays is doing the similar to wavelengths, AWS wavelengths in collaboration with Verizon and multiple telcos. We're more thinking about from the platform perspective. We run the compute at the edge of the network. Now here's a platform, you can run different kind of applications on the edge. Depends on how you distribute your workload, how would you like to run applications and meet the needs of your own customers. So the definition can be very wide, can also be very narrow, depends on who your customers are.
Simon, I believe you're on mute. And believe you're still on mute. There you go.
Now it should be off.
Thank
Sorry. I think it's important to differentiate between the different edge use cases. Otherwise, my iPhone is also edge computing and yeah, whatever, So that's kind of boring. I think what's interesting is to tackle it from the perspective of the value to a customer and the extent to which they actually bundle together software and or hardware to make a solution, or somebody does, right? And so there'll be lots of embedded things where somebody else has decided that this product is what I need to buy. It's just a smarter product. And yeah, sure, everything has a CPU in it, and that's kind of boring unless you're Intel. But ultimately, the goal here is to enable more and more applications to be built by more and more people that take advantage of computing capabilities closer to the edge, closer to the physical edge. And so as a software guy, I care a lot about the capabilities we can allow for developers to take advantage of compute closer to them to develop rich applications.
So we've heard from all of you kind of an idea of why this is important or why this is gaining attention from a lot of people who are looking at today's computing models and seeing the need for something more, the need for something that addresses their own use cases. Why is this hard? we understand why people want to do it, but why have people had trouble implementing this type of art scenario? What are some of the current challenges that make it difficult for companies that might understand how to deploy applications on a cloud, but don't necessarily understand how to work in this world? What are some of the common things that you all see when you talk to your customers and others as they try to get started with edge computing?
Well,
Farah, go ahead.
sorry. Edge computing is just an entirely different landscape than anything we've seen before. There's a different type of hardware that we're running. Often, I think Steen brought up, there's legacy hardware out there, and so trying to create a platform or a set of applications that would run uniformly across these different types is a challenge. Connectivity is an issue in the cloud or on a data center. You expect high levels of connectivity at the edge. If you think about an edge being, maybe like in ag tech or in oil and gas, you don't have that high level of connectivity that you've come to expect. You're running on cellular or other things, connectivity drops out. And so you're dealing with a whole different set of issues. And then security is a major challenge as well. Again, in cloud and data center, you only have the limited access to the people who are supposed to have access to the infrastructure. Out of the edge, that's an entirely different model whereby, things are running, like I said, on physical devices, could be running on a bus or a train, and people could have access to that. And so you have to think about a lot of these things in a way we haven't had to before.
For me, it's all about the volume of data. Let me give you some silly little numbers. The city of Las Vegas, just the traffic lights, produce 64 terabytes a day. Okay, and they're stupid old lights. They're about 30 years old. And yet, if you want to do a better job being a smart city, predict what's going to happen in the city, you have to process that. And so data is ephemeral, but it's very voluminous. And you cannot afford to store all that and think about it later. In our biggest application at Swim, we're dealing with 4 petabytes per day. Okay, and that'll be more than 20 petabytes per day shortly. And this is just unthinkably large in terms of the volume of data that you have to deal with. But again, it's ephemeral. And so in many of these applications, you have to make sense of the world and get a response back. And storing and analyzing later doesn't make sense. And the volumes are so high, you couldn't do it anyway.
Yeah, add to it, I think on top of that, there is also customers adoption awareness issue. Edge computing in general, this concept is relatively new, and only recently in the past a year or two, and the entire industry started to pivot and focus on, well, edge computing with the value around it. At this moment, whenever we introduce new technology, I think there's a pushback in terms of, is this going to disrupt my today's technology? My today's technology is kind of okay. Do I need to be the early adopter? Should I wait until 3 years later, someone else tests out, and then I can fully realize the true value to myself? So this is more adoption awareness from the customer perspective. On top of the technology issues, I think like Sam and Farah and brought up lots of tech issues. And another thing when you add to the tech issue is the data synchronization among edges. So imagine this, if you have thousands of edge nodes. So I launched the Verizon Wavelengths or 5G Edge, the product in collaboration with AWS together. And sometime in the future, there'll be a lot of edge nodes. How would you be able to quickly synchronize data among all the edge nodes without duplication and doing it fast? This is also another challenge out there. The second part of tech issue is also the workload orchestration between cloud and edge. I don't believe that in the future, there's only edge, there's no cloud. It's always percentage of your workload is in the edge. And when necessary, cloud is more feasible, you send it back to the cloud. How would you do workload orchestration among edge and the cloud, and also multiple clouds? They will like Azure and AWS and Google Clouds. How would you do that very easily moving forward is also lacking. And the third part, what I think is challenging for the entire edge space is the developer ecosystem. I think Sarah mentioned that a little bit. I just want to emphasize on this because it is harder to be the only one the only early adopter, the only one, like number one sounds easy, but when you apply any new technology into this new platform, the ecosystem is very necessary to boost the deployment of any new tech.
Yeah, I'd add two more things on the technical side. The other thing to keep in mind is that this stuff is dynamic. A traffic light may not change that often, but if you got equipment on the factory floor, if you got equipment in your retail store, in your hotels and distribution centers, that equipment gets changed a lot. It gets moved around. It gets reconfigured. It gets repurposed. I tell the story often. If you're a factory manager and you've got a job to get done today, and you have a piece of equipment that goes out on you, guess what? You're going to swap out that equipment and replace it with something that will allow you to get that job done. You're not going to wait for change control to go through IT to get that update made. So getting the right software to the right place at the right time in the midst of all this kind of change is really a major issue. And Nancy hit on this. I mean, I'd come back to the point of scale, and scale not just from the standpoint of the amount of data, as Simon pointed out, but also, or even from the standpoint of how do you orchestrate between your cloud and edge. But now think about the management task, getting the right software at the right place at the right time when you've got dozens or hundreds or maybe thousands of different pieces of equipment, each of which have to have their own piece of software running, doing the right thing at that location on that piece of equipment, and doing it in a way that is relevant to the overall thing that you're trying to do as a company. I think that all of those, all those issues of dynamism and diversity and security and everything else that everybody's mentioned is amplified when you have to deal with scale and the complexities associated with that. And if you don't find a way of, in fact, frankly, in my opinion, if we don't as an industry find a way of standardizing on the technique for managing this software, the cost of managing it could quickly exceed the benefits that edge computing brings to the table.
Or there'll be a bunch of vertical solutions, right?
Yeah, but if you're a factory manager and you've got equipment from 20 different suppliers and each of them has a different management technique.
Oh, what a nightmare.
That's,
yes.
I think both Rob, Nancy, and Simon make a great point about the dynamism of software. And one of the great things about edge computing is that you're actually decoupling the hardware from the software now. So, hardware refreshes at a very different life cycle, maybe every 3 years or so. Whereas software, you want to be able to be dynamic enough, especially when you're thinking about like AI. And so, when we're seeing from our customers, they're deploying these AI models. AI models is something that, you want to train and update on a regular basis. So having the ability to manage that capability and update that on a much faster basis than the hardware changes is definitely important. This is something that IOFOG is actually focused on. So rather than focus on the applications, we've focused on the infrastructure and how do we standardize that? How do we manage and orchestrate and deploy these applications? How do we get granular enough so that we can group different functions together, different edge nodes together, and say, okay, these edge nodes in Arizona, run at a higher temperature, and so we want to deploy the set of applications with a different threshold than somewhere in Boston where things are at a cooler temperature. Or I think Steen had mentioned GDPR. We want to clump these edge nodes together and say, okay, these nodes cannot leave this factory floor because of requirements as it relates to GDPR. And so I think there's a massive opportunity there especially if we can make these developer tools simulate or mimic the same paradigms that we've seen in the cloud. Then we could take our existing cloud developers and enable them to develop from the edge without having to change their way of development, without having to change their tool set, and really unlock that potential power.
So I heard three sort of common themes across what all four of you were saying in response to the challenges. And let's take each one of those and break them out a little bit more. Basically, what I heard from you all was that there's a ton of data generated by edge computing devices, and managing that data and learning from that data is its own challenge. That operating models are still evolving in terms of how software and hardware work together and across cloud providers, telecommunications companies. and developer tools, how developers are given tools to be able to access these capabilities, and you know, what we're learning about what developers need to be successful at the edge. So let's start with data and AI. How are people using edge data right now in order to inform their own strategies, using machine learning algorithms or using data sets? You know, you mentioned, all of you, of course, the operating challenges at the edge. You know, you don't have supercomputers at the edge. You have devices that are operating under a set of constraints, but yet you have all this data, this rich data that's being produced by these edge devices. How are companies using this rich data and machine learning to unlock new insights into the way their applications or their systems are running?
I'd love to hear from Farah first. I have some strong views, but go ahead.
Yeah, so you know, AI has been actually a huge driver of our use cases, and primarily because, you know, when it comes to IoT data, a lot of that data was smaller, and, you know, quite frankly, it wasn't an issue to ship it back to the cloud. When you're thinking about AI, and particularly where we see a lot of uptake is AI over video. There's a lot of video that's generated at the edge, and you can't send all of that data back to the cloud to get processed and then, you know, process that and send that answer down. A lot of times that data is also, there's a lot of it, but not all of it's useful. If you think about, you know, video again, 99% of the time there's not a non-event happening, and only that 1% or 10% of the time you see something and then you want to process it and take some sort of action. And so this is, I think, a huge opportunity where Edge is a valuable asset, because it enables us to process that video at the edge, send back the things we care about. So in the case of one of our customers, it was actually doing search and rescue for a government out in the East. And you know, they were actually collecting cell phone video from their first responders. They wanted to process that video to find bodies or other things that they needed to account for so that they could send their search and rescue people to the right places. Again, time was a massive issue. A lot of the time, the cell phone data didn't actually have anything of note, but in the times they did, they needed it processed quickly and they needed an answer fast. In that case, you couldn't actually send all of that data back to the cloud for processing and come back because of connectivity issues. But moreover, you didn't have the time to wait for it. And so, you know, here's a real world example of where AI and Edge came together in a really meaningful way.
So let me dive in. In the swim world, we're dealing with vast amounts of data which is streaming from the edge. And so what we do is we build models from the data on the fly, and those models train themselves from the data. So I mentioned traffic a while ago. I'll go into a mobile use case in a minute. Here's a use case for you. I want to sell predictions for the way that the infrastructure is going to evolve in a smart city, say Las Vegas, to Uber and Google and so on, so that vehicles can plan their routes better. So in the swim world, what we do is we learn on the fly that these are sensors, and sensors belong to intersections, and intersections learn they have neighbors, and then they collaborate to predict ahead. And so without storing data, we're able to predict ahead, and each one of these, I guess you can think of them as digital twins of an intersection, can predict with good certainty, good accuracy anyway, its own future. And those predictions can be streamed to Uber or whoever the customer is. And so our challenge is not so much training models using humans and storing data and so on. It's picking our way through data on the fly to build models that train themselves. Now, a mobile use case is to identify cell towers that have got low coverage or that are out, and identify the customers that are affected, and to move the customers to other cell towers so that they get better connectivity and so on. I'm happy to go into these in more detail. The key point here is that in my world, we build the models from the data, and then the models train themselves. And that, I think, is hopefully a scalable and useful way to deal with massive diversity of types of data and volumes of data at the edge.
Yeah, I think there's one other thing that factors into all of this, and that is, what Simon's talking about, I think is good when what you have available to you are machines that are capable of having enough compute power to perform the training and then, of course, the inferencing. And I think there's been a tradition where we have assumed that the only place where you have that kind of power is in the cloud to do the training, and therefore the only thing you could really do at the edge is inferencing. I think that model that separates those two worlds is going to start to transform over time. It's going to start breaking down. We're going to see more and more compute capacity starting to show up at the farthest furthest endpoints of the edge. And maybe not all at once, because we still have a lot of legacy hardware out there that doesn't have that kind of capacity on it. But what I do think is interesting, and Farah brought this up really early on, where she talked a little bit about this continuum from the cloud on out to the edge. If we assume for a moment that the prevailing software engineering technique is to at least containerize your workloads, and that is sort of a well-formed, accepted software engineering practice, and we have the ability to deploy containerized workloads, whether that's running on Kubernetes or even just on an OCI compliant container runtime like Docker or Podman or whatever, we now on all the different tiers of the edge, whether that's a network edge or the edge clusters or the edge devices, we now have the ability to make true measured trade-offs on the cost benefit for placing workloads at any one of those tiers. And we have potentially the flexibility to move that up and down the tiers as those things change, as more capacity occurs out at the edge, or perhaps there's other economic conditions that require that we reduce the amount of capacity at the edge, or as the need to consolidate increases. And so I think there's this symbiotic relationship between cloud computing and cloud native development practices, the availability of compute resource and the capacity that's needed to do any of these different kinds of workloads. And then, some of the points that I think Simon's bringing out, which is, these new techniques of, AI development, training, processing, et cetera, that perhaps is a little bit more autonomous and a little more autonomic and less, dependent upon human curated training activities. That I think will allow for us to evolve as this world changes in front of us.
That's so well said, Rob. I think some of the principles you're talking about, fall exactly in line with the edge native computing principles of containerization and the ability to dynamically move applications. So I think that's just spot on.
Yeah, I just want to throw in one thing, which is that the dominant pattern in cloud native is REST and databases. And, REST is really stateless, which allows any old server to do the work for me, and databases are databases. And every time I reach a database, I'm looking at 10 to 20 milliseconds of round trip delay. So the combination, even if you take it as far as Lambda or functions as a service, this stateless notion of compute in the cloud serves cloud computing architectures very well, but it's really atrocious for high rates of events from the edge. So let's go back to my example of Las Vegas. I'm looking at 30,000 events a second from not that many traffic lights, but sure, there are 5,000 servers in AWS Lambda, and each end-to-end event time to update my database is maybe 150 milliseconds. I can do that, but it's going to cost a bunch of money and cost a bunch of time. And so it makes sense to adopt a model which is actually very simple, and we all know is true anyway, which is stateful computing. So the reactive paradigm, Swim is kind of a reactive type of environment where things compute statefully from event to event, and that statefulness closer to the physical edge makes a ton of sense, because if all your cloud ever does, or all your infrastructure ever does, is update database, you're sitting at the far end of 150 milliseconds, and that's just too slow.
On top of that, in addition to all the technical issues we mentioned, what I think the challenge, let's say for all the AI and cities for influencing today is that lots of old equipment today, they're not up to date, which means a lot of dumb equipment out there, they do not have AI. Yeah. Especially for cities, because in general cities have limited fundings. We can imagine almost every other intersection has smart cameras or traffic lights, things like that, right? But not all of them are smart. Now where edge computing comes in is saying, if I'm able to take the data we collected using the dumb camera who doesn't have AI today, but I run AI in my edge platforms and immediately trains data and inference, it's mainly inferencing data, and send data back into your dumb devices. And in that case, we're able to help those cities to upgrade the infrastructure in a much cheaper way and much faster way. So
yeah, that's right. I think that's perfect. I mean, your average traffic light says I'm red about 5 times a second. It's really stupid, right? And so, but we still have these infrastructures smarter by the addition of, more, whatever, newer architectures, same ways of processing all that stuff and not kill the cloud.
So that's actually something I just wanted to get into, that our next segment, that we've been talking about this problem in a couple of different ways, right? In terms of cloud providers coming down to the edge, but then also telecommunication companies who have a lot of equipment already at the edge coming up into a cloud world. And we started to get into this a little bit. And Nancy, we actually had a question from the audience sort of around this topic. Can you elaborate a little bit more and say what is the advantage or one advantage of having all or most of the power on the edge of the network as opposed to the cloud?
Great. I know this is a question to me because I launched the 5G Edge for Verizon and in collaboration with AWS Wavelengths. And let me recap the question. So what is the advantage of putting all the workload to the edge? And first of all, I disagree that we're going to put all the workloads to the edge. It's always a percentage of the workload and also the dynamic part of workload, like orchestration between edge and the cloud. This is what I illustrated earlier in this part regarding orchestration. Now the question more tailored towards what happened to the edge, like the telco edge, right? What the advantage of moving certain part of workload to the telco edge. And this opens up many different ways. And first of all, let me give you guys the high level value prop when we talk about moving the edge to the workload to the telco edge, is that first of all, we're able to see low latency. I think low latency compute is very straightforward for all of you guys to, we talked about this earlier. And the second is cost, that if you're, which is also the use cases, the AI use cases we mentioned. If you're able to process lots of data directly on the edge while you're sending data back and forth to the cloud, it's saving your transport cost. In addition, it also saves the cost in terms of the infrastructure upgrade, which is also the example, the use cases we mentioned earlier. Now, the third part, which I want everybody to start imagining with me in this like coming 3 years, what does it look like, is that actually edge, the telco edge is able to transform the business model of lots of companies. One of the example is a real one that you guys know this, that Tesla stock's going crazy. It has nothing to do with the stock, but their technology, the way they build their tech, let's say, I think 2 years ago, there was a competition regarding who drives the fast car, Tesla or the traditional like racing cars. Of course, the first time they did competition, Tesla lost. And then Elon Musk immediately jumped in saying that we are going to do a software upgrade. And they did a competition again, and Tesla became the fastest car 2 years ago. So what this means is, if you're able to run and upgrade your software that's independent of your hardware, you're able to soup up your car or other existing hardware component very quickly. And imagine this, if the robot today, right, lots of machinery, all those robot applications, they're all based on physical robot. If you're able to run edge computing for those robots, which means I can retrain my robot to do many different functions without buying new equipment. And then the physical design of the robot could also be very light and smaller, potentially could be safer as well. Then we transform the business model of existing hardware and different companies today. So therefore, the value itself is more than just processing data faster, could also push another revolution of industry changes.
So just, if you wouldn't mind me just being a little controversial and talking about performance, I agree with you 100%, by the way. You know, I said if you use just cloud abstractions, you'll find yourself on the bad end of 150 milliseconds. That's 1,000,000 times slower than Raspberry Pi. Okay, let me say it again. It's 1,000,000 times slower than Raspberry Pi. So, you know, when we think about performance, we assume models are in place, like REST and databases, and my God, that's just too slow, people. And so there are tons of computers at the edge, like my laptop from 3 years ago, which is a fabulous Intel device, which is really good at solving quite complex problems, okay? So it doesn't take a complete upgrade of the edge compute infrastructure. It takes the modest addition of modest amounts of compute, and my God, you beat the cloud hands down.
Yes, that's, I think the example you give us, I push it towards the compute on-premise, but like in smaller devices. And those applies to specific segment that assuming your workload today is not that big or big enough to process locally. But the platform, the telco edge is able to provide is more towards if you bring multiple workloads together, that one to your computer want to talk to my computer, and in Sarah's computer, which is all live in very different locations, how would you do multiple computers communication and do more fancy stuff? That's where
so I think the telco edge is awesome. I think it's going to transform business. Absolutely.
That's my
good, Nancy. Tom, I want to latch on to something that you said in your question, and you used, I think, the term cloud out, or at least you used the examples of Outpost and Wavelength as examples in your question. I do think it's useful for all of us to be conscious of sort of two macro motions in this edge computing marketplace. One being what I call the cloud out motion, which is largely what we see when the hyperscalers are bringing their cloud compute capabilities into the edge, and Outpost, Wavelength, Azure Stack are all good examples of this. And that, you know, that has benefits for people who I think have, you know, accounts on a particular hyperscale cloud environment, who have been building applications, maybe collecting data, have making use of certain platform services. It's particularly convenient to be able to bring that out into when we run essentially the same platform, you know, in a network edge, or even all the way out to an edge cluster. But I also think that at the same time, we have to be conscious of the part of the marketplace that is looking for cloud agnosticity, and whether it's for technical reasons like Simon's describing, which is, you know, so the constraints that you might run into if you were to do certain workloads in a cloud architecture, or for other reasons, which is, hey, I don't have a commitment to one hyperscaler. I actually have to use multiples, right? I have accounts on different hyperscalers, or maybe I don't have any at all, or perhaps I've got some stuff in my own IT data center. Maybe it's my own private cloud. For that, I refer to that as sort of the edge in motion. You know, people who are trying to build from the ground up for the edge. And by the way, they want to connect to the cloud. They want to connect to their IT data center. And I do think that both motions are relevant. What we have to think about is what are the control points within those that allow people to have the flexibility to choose what they need to when they need to do that. And interesting enough, to kind of bring back Nancy's comment in a different way, what's interesting is if you look at the two motions, they intersect at the network edge. So I think the network edge is going to become one of those control points where, you know, cloud out meets edge in, overlaps, maybe bypasses each other, but it becomes a control point that enterprises need to be thinking about when it comes to what are your strategic intents and how are you going to manage for that. So I just want to kind of highlight that, because I think that we shouldn't just simply accept the cloud out strategy just because that's being made available and it's convenient. There's a certain risk associated with that we have to be conscious of and understand and mitigate those risks where we need to.
Absolutely, great point. Especially because I think that the people who are doing cloud out have a vested interest in getting that data back into their clouds. And so they're not necessarily focused on how do we make the edge processing the best experience possible, but still, looking at getting that data back into their cloud. Not to hate on our friends at Amazon, but recognition, their facial recognition like application, we saw being used recently was designed to do that, to take the data and then send it back to the cloud in order to do facial processing. And again, from a data standpoint, it couldn't ingest it fast enough and it couldn't process it fast enough, and the bill was, enormous. But to your point, you're right. People want to have the flexibility to send data back to any cloud or not have to send the data back at all. I mean, in some cases, they're sending it from edge to edge, or stopping at a different layer up. Like they may go back, to their colo, they may go back to the data center, they may aggregate data at a micro data center and not necessarily need to go back to the cloud. So one of the differentiators about the edge is the dynamism that you kind of brought up a couple times, which I completely agree with. So obviously I'm a big fan of the edge up, but I don't think cloud is ever going to go away, nor should it, because it has real applications and real uses. And it really depends on the application, what you want to do and where you want to store that data. And so just having that flexibility is important.
So we have only a few minutes left, and I wanted to make sure we got to one last part of our discussion, which is to acknowledge the folks who are going to have to actually deal with the rise of edge computing, and that is the developers, the people within companies that are going to have to understand how to architect their applications for this type of structure, should it make sense for their companies. Can all of you give me a sense of where things stand at the moment in terms of developer tools that allow this to happen? What needs to happen in order to make this easier for people to take advantage of, and more or less how you think that'll play out over the next couple of years?
I think as much as possible, if you can leverage existing developer tools, or at least try to mimic existing developer paradigms, you have the best chance of being successful. And so, what we at Edgeworx focused on in developing our open source platform, IOFOG, is exactly that, leveraging existing, developer tools and CI/CD pipelines, allowing them to develop with their existing languages, such that we can unlock cloud developers to deploy at the edge. Letting them leverage things like Kubernetes, which they're really familiar with, and then around that, creating the Edge Native Working Group, which brings in other companies like Intel, for example, Bosch, Siemens, telcos like Ericsson and others, to come together and sort of define what that looks like.
Yeah, I think there's two things here. One is Farah was hitting on it here, and I think Farah, you used the term edge native development earlier as well. I do think that edge native development is an important idea. In my opinion, edge native development is largely first cloud native development, meaning it's picking up a lot of the same software engineering principles we talked about before: containerization, componentization, separation of concerns, loose coupling, statelessness where you can, et cetera. But then adds to that the additional need to focus on things like, hey, you're operating in a resource constrained environment. You don't have elastic scalability over infinite resources like you might in the cloud. You have to worry about, the internodal latencies that you have to deal with when you're constructing or architecting a multi-tier distributed computing application. You have to worry about the fact that connectivity may not always be there. You can't always get the resources that you think you need, depend on, so on and so forth. So I do think that there's this idea that edge native is cloud, but it adds some additional dimensions to it. But I also think there's another dimension, which is, and probably hits a little bit on both Farah and Simon on the work that they're doing. When you're operating in a resource constrained environment, even things like the machine learning model that you might typically depend on has to be thought of in terms of what kinds of compression do you need? How do you make the model more compact without regressing too much of the accuracy that you need? What's that fine balance between the right level of accuracy versus the level of constraint that you have to deal with? And I think from a software engineering standpoint, that puts a burden back on software engineers that I think perhaps we haven't had to deal with in this community for at least a decade or so. And it's important discipline to get back into to really measure the engineering trade-offs between performance versus resource.
Yeah, there's no such thing as a free lunch, particularly in the AI world. And so it's not something you can just sprinkle on a solution and magically you're right. I agree wholeheartedly that the trade-offs are very real and that you have to evaluate what adequate accuracy is for the purpose. So I think what I'm seeing is majority of applications are cloud native in intent. That is, they're not some old on-prem thing unless they have to be for compliance reasons. They tend to be using the primitives of the cloud and the large open source infrastructure components, which from the Linux Foundation or Apache or whatever. And so embracing that development style and those developers and Kubernetes and so on as the way that people are going to deploy these apps, and then giving them the tools to quickly build complicated things which will turn out to be complicated runtime, but to easily build stateful analysis pipelines, which take care of most of the complexity for them, is certainly a key focus for us. And that must be open source.
Add something to it. We already touched upon the cloud native. I cannot add anything to it because all perfect answers. I just want to add something to the developer communities. I think the tools are necessary for developers to easy transition between edge and cloud. Communities is also very important. The community part is, you can imagine how developers make decisions today. They like to discuss with their peers, have very heated discussion, doing some hackathons. So those communities is necessary for us to bring the ecosystem from cloud to make them feel like there's a hashtag like edge developing trend as well. Something I think there's a lesson learned quickly from the blockchain space, as right now it's going crazy. So but there is an observation regarding which blockchain itself has a better developer ecosystem. Ethereum has the biggest and also the best developer ecosystem. Even if there's other chains out there has a better performance than Ethereum. However, I have seen other developers jumping from the new chain, new platform back into Ethereum was because their friends are there. And also if you want to integrate with other applications for collaboration, they're all in a different platform. So the ecosystem, what I believe is also the key to win in the long run.
Yep.
Well, that's about all the time we have today. Thank you all very much for being part of this discussion. Thank you to everyone on the other end. And also thank you to Rob, Nancy, Simon, and Farah for your time. And of course, also thanks to Intel and Steen Graham for putting this on today. Please continue to stay in touch with us for upcoming events. We have an event next week on the state of the cloud that you can find more details about on our website. And please sign up for the Protocol Cloud newsletter on our site as well and learn more about some of these topics as they evolve. Thanks once again, everyone.
Thank you, Tom. Thank you, guys.
Thank you.
Yes.